Well, thank you, Frank. I must say that, and I know it's a cliche to say this, but I'm really excited to be here today. Speakers always say that, and you go, yeah, we've heard that. We've heard that before. But as CTO of Intel, I give a lot of keynotes, as you might imagine. And I know Frank said this was the largest audience he talked to. This is one of the smaller audiences that I've talked to of late. If you're not 4,000 or 5,000 people, hey, it's hardly a crowd. But most of those keynotes don't really have some standout item, something that you'll reflect back later. In the long light of history, people say, that was a really important occasion because something very significant got announced. And I think we're going to share with you what we think is a true technological milestone. Frank's previewed it a little bit, but I'm going to tell you more about it in just a moment. Before I start, I'd like to just speak to Intel's collaboration with Facebook and with the Open Compute project. Frank, I think, did a good job sort of catching you up on all the history. I want to just highlight what Intel's been doing. So, I have to say that Intel is really fully and actively engaged in the OCP effort across the board. It's really been I think a terrific experience. I think we've moved beyond what you might call a customer-vendor relationship. It's been much more of, grab the marker, go to the whiteboard, and start innovating. And it's really the case where each company, not just Intel and Facebook, but all the other members of OCP are really bringing their best ideas to the table. And I think much of what Frank said really speaks to that. So if I can have the next slide, guys. All right, well, I'll try to do it. Nope. Yeah, okay. Well, that's the exciting part of today's speech. So let me get the slide content up here. No, wrong slides. Okay, I'm patient. Don't know what they're doing. I know they have the slides. I've seen them. No. Come on, guys. All right, that's better. We're almost there. Yay. Okay. Thank you. All right. We'll talk to these folks afterwards. All right. So I've talked about the history of the collaboration. Let me actually talk about what we've been doing. The OCP effort, I think, creates tremendous opportunity across the industry, not just opportunity for Intel, but for everyone involved in data center architecture, design, and development. We've developed our own products that are in compliance with OCP specifications, and we've worked with multiple industry partners. And as you can see here from the graphic, now that we finally have graphics, we've developed motherboards, various kinds of rack technology, worked with other partners to do storage and I/O solution, as well as management technology. So there's been a lot going on, a lot of progress, again, as Frank said, has been made over the last several years. And what we're announcing today is just the next step in what we see as an active and ongoing relationship with Facebook and the rest of the OCP community. Hey, that worked. All right, so I consider myself something of a student of rack architecture. I believe, and you can all email me if you think I'm wrong, but I believe I built, well, I'll soften it, one of the first blade servers ever built in 1985. I would say a fair fraction of you weren't even born in 1985, but it was based on the Intel 286, 287 microprocessor, and each one of those blades had 8, if I'm not mistaken, 7. Intel Ethernet controllers on it, and the fabric for this design was an n-dimensional hypercube based on those Ethernet links. And the very first one we sold had 128 blades, and it went to Yale University. Today's IP data centers are seeing an incredibly rapid evolution of their architectures. And as Frank said, the emphasis now is on disaggregation of those resources. And I think Frank gave you good illustrations of that. I never thought of it this way until we started talking about disaggregation for OCP, but we actually had all of our we had a common set of power supplies for the rack. So at least we had disaggregated the power in that old design. So as we look at what's being done today, sort of the first step in disaggregation is that where we're trying to reduce the sheet metal. We're consolidating things like power supplies and fans and so forth. The next step is really to address fabric and switching and see some of the early opportunities to disaggregate by focusing on storage and I/O. Critical to this step, we believe, is the introduction of silicon photonics in the design of not just the inter-rack fabric, but the intra-rack fabric, and we're going to show you that, all based on silicon photonics. Once that infrastructure is in place and other technologies evolve, we believe we can do further disaggregation, and probably the last big step is to disaggregate processing from memory, compute from memory. You can't do that today, but in the next few years, we think that's going to be possible. So Intel has been working now for some time to create the underlying technology for that rack fabric, and we talk about creating a photonic rack architecture, and that's what you see illustrated here. Now, disaggregation is certainly possible without silicon photonics. I like to think of silicon photonics supercharging this notion of a disaggregated rack and giving it the bandwidth, the capacity to let the individual technologies, the individual resources, if you will, in the rack to advance at their own pace. In some sense, we're over-provisioning the fabric in the rack to allow for multiple generations of technologies to evolve within that common rack framework, and obviously having a big impact on total cost of ownership. The illustration here, I think, gives you a good sense of how we're approaching it. The silicon photonics module is initially 100 gigabit per second design very cost-effective, very reliable. You can talk to it either via Ethernet or via PCI. We have a couple of mezzanine options, as you see illustrated here. And that module, if you will, sits in the back of the rack. And then these sleds plug into it. So there are different kinds of designs. We can use Xeon class servers to populate the rack, or we can use Atom class servers to populate the rack. And in fact, we're doing just that with our new Avoton microserver design. The fiber that emerges from the mezzanine is then routed to the front panel, where it can be cabled to the top of the rack and interconnected into the rest of the rack environment. So we're already well at work on enabling this technology for the Open Compute project, and you'll be able to see this. We have an Avoton SoC memory module. I think Frank showed you that. We have the tray-level switch module. In both of those cases, we either have a spec in development or a spec planned for development. We also have 2-socket Intel Xeon server boards. You'll be able to see that. And we've been working with Corning, one of the leaders in fiber optic cabling technology, to create a new connector for Intel silicon photonics technology in the rack, and you'll be able to see that. And we now have in draft form a specification for what we call the Intel photonic rack architecture, and there's a design guide available for that. You can see the mechanical mock-up for this photonic rack architecture, both in the Quanta booth. They've been our partner to develop the mechanical prototype, as well as the Intel booth. And you can see all these bits and pieces. So if you make it out to the show floor, be sure to catch those two